Hicor Technologies presents a revolutionary new hybrid rotor compressor that can efficiently compress wet gas at ratios of 40:1 or higher. The shale gas revolution has stimulated tremendous production of oil and natural gas in the United States. While this has been a huge win for the industry as a whole, it has driven a sharp decline in the price of natural gas. However, many natural gas wells also produce liquid hydrocarbons, such as propane and butane. These so-called natural gas liquids, or NGLs, have seen their prices remain relatively high. As a result, wet natural gas plays, which have significant NGL content, are becoming increasingly attractive to producers and operators. The challenge with these wet natural gas plays is that conventional compression equipment is unable to tolerate liquids. In a conventional wellhead scenario, the liquids and gases have to be separated and dealt with independently, with only the gases passing through the compressor. With Hicor Technologies' solution, both liquids and gases can pass through the compressor into a single multi-phase pipeline. In 2010, the Hicor Technologies team set out to design and build a new type of compressor, a compressor designed to be much more compact and efficient than existing equipment. A compressor that represents the first breakthrough innovation in the compression industry in over 50 years. An innate problem with compressing a gas is the heat generated as a byproduct, which serves to make the process less efficient by turning some of the input work into heat instead of pressure. As the gas being compressed heats up further and further, the compression process gets less and less efficient, effectively limiting compression ratios to 5:1 with many traditional technologies.
We solved this problem by developing a proprietary cooling technology that cools the gas as it is compressed, thereby improving the efficiency of the process by 30% or more. The cooling process further allows dramatically higher compression ratios of 40:1 or more. This allows compression applications to be accomplished in a single stage versus 2 or 3 stages with traditional equipment, reducing the complexity and the cost of the full compression package. Our proprietary compressor design uses a novel rotary geometry, which provides a number of additional benefits as well, including fewer moving parts, less vibration and noise, a variable compression ratio, and high suction efficiency. The unique rotary design also allows liquids to pass safely through the machine.
This not only enables the cooling technology, but it also allows the machine to be used in wet gas applications, eliminating the need for wellhead separation of liquid and gas, and instead enabling producers to operate a single multi-phase stream from the wellhead to a central processing facility is a truly game-changing innovation. Hicor Technologies took a novel approach and designed a compressor with a hybrid rotor geometry and innovative cooling system. Now, let's take a closer look at just how this technology works. The first thing you will notice is the Hicor Technologies compressor looks much different than a traditional piston or screw compressor. To better understand what makes this unit so special, we will look at 3 aspects of the design: mechanical operation, thermodynamics, and wet gas compression. Mechanical operation. The basic operation of the compression is a rotary motion, with the compression chamber being centered around the main drive shaft, creating a compact machine. Compression is accomplished through a sweeping motion of the main rotor. The rotor is a proprietary non-circular shape, which is dynamically balanced for concentric motion about the main shaft. A vane moves in sync with the rotor, sealing the high-pressure portion of the compression chamber from the low-pressure chamber. On the other side of the rotor, a constant radius dwell section of the rotor forms a non-contacting seal with the outer casing, completing the sealed compression chamber. Because of the high pressures and power that the compressor is capable of, the forces are too high to allow the vane to ride directly on the rotor. Instead, an external cam drive with spring returning force is utilized to maintain the vane at a constant distance from the rotor. Gas enters the compression chamber through the intake until the full chamber volume is achieved and the rotor covers the intake. As the rotor continues sweeping around, the volume of the chamber is reduced and the gas is pressurized. Once the pressure of the gas exceeds the pressure of the downstream piping, the discharge valves open, allowing the high-pressure gas to exit the chamber. Thermodynamics. A challenge with traditional compression equipment is the heat that is generated as a byproduct of compression. This heat not only makes the compression process less efficient, but also limits maximum achievable compression ratios, typically as low as 5:1. To combat this, Hicor Technologies has developed a proprietary cooling technology. Liquid coolant is atomized and injected directly into the compression chamber. Because the heat capacity of a liquid can be 1,000 times higher than that of the gas, the liquid absorbs the generated heat with minimal temperature rise. Traditional compression equipment is not able to utilize this type of cooling, since those machines cannot tolerate liquids in the compression chamber. The rotary motion of the Hicor Technologies compression process sweeps all of the liquid from the chamber during each rotation, eliminating liquid buildup. The discharge is located at the bottom of the unit, allowing gravity to help in discharging the liquids. These features allow liquid to safely pass through the compressor without experiencing the hydrolock conditions seen when liquids are present in conventional compressors. Hicor Technologies' proprietary cooling technology can improve compressor performance by 30% or more, as well as enables compression ratios of over 40:1. Wet gas compression. Because of Hicor Technologies' unique design, it is capable of passing liquids through the compressor. This not only enables the cooling technology previously discussed, but also allows Hicor Technologies compressors to be used on wet gas streams without the need for separating the liquid and gas. Multi-phase flows with gas volume fractions as low as 80% can be passed through the compressor. The gas portions are still compressed while the liquids pass harmlessly through the machine and are entrained in the gas stream as they are propelled through the downstream piping. This capability allows wellhead operators to operate a single multi-phase pipeline to a central processing facility instead of having to separately deal with the liquid and gas streams, resulting in dramatically lower cost and complexity.
Our team has made tremendous progress in developing this breakthrough technology and is looking forward to delivering a game-changing innovation to the natural gas industry.
For additional information on Hicor's compressor technology, contact us at www.hicor.com.